All right, I'm excited to get going on our next unit, and we're kind of winding down the year, so we're getting toward the end. But this is one of the more important units in all of our curriculum, and that is volume. And it's very practical too. So the first volume we're going to talk about is the volume of a cylinder. And as you look, there's the formula for finding the volume of a cylinder. It's just pi, which we use 3.14, times the radius of the cylinder squared times the height. And why do we use that? Well, let's show you. First of all, we know that a cylinder has a circular base to it. The top and the bottom, when you're looking at a cylinder, is a circle. And so in order to find the area of that circle, we have to use pi times the radius squared, the formula for the area of a circle, to find that total area. And then once we find the area of the circle, we multiply it by how tall or how long the cylinder is, and that gives us the volume. So if we look at the volume, if we look at a rectangular volume, to find that we would just go 2 times 3 times height, or 5. So length times width times height. So in this rectangular shape, it would be 30 cubic meters. And if you could look in there, you could count the blocks, 1, 2, 3, 4, 5, 6, and so on, until you had all 30 counted. Well, a cylinder is very similar, except it's got a different shape to it, but we can calculate exactly how many cubic blocks would fit into that cylinder. So to do that, the volume of a cylinder is, the volume of a cylinder is the total space, three-dimensional space inside a solid 3D figure. And we know that the area of the base is the area of the end, so in this case the area of this circle, and we know that the radius is the distance from the center of the cylinder to the outside edge, and then the height is how long the cylinder is. So here's the formula. We've kind of mentioned to it in the beginning, but the total volume is the area of the base of this cylinder times its height. And the area of the base will always be pi times the radius squared of whatever the base is. So let's try this out. So here we've got volume equals pi r squared times the height. Let's list the elements that we have here. We know that pi, we're going to use an estimate for it because it's an irrational number, and we just want to go out to 2 digits here, 3.14. We know that the radius of our circle is 5, and the height of our circle is 6. So let's bring in a calculator and do this calculation. So we're going to do 3.14 times 5, and it's squared, right? So I'm going to square it, and then times it by 6, which is the height of the cylinder, and I end up with 471 units. So the volume is 471 inches cubed. And we got an integer answer, so we didn't have to do any simplifying or rounding. Okay, for our next one, we've got volume equals pi r squared times height. So remember 3.14. R is 3, so we're going to put that in there. 3 squared, and the height is 6. So bring our calculator back in, clear it out. So 3.14 times 3 squared times 6 equals 169.56. So 169.56. Now this doesn't say anything about rounding, so I'm going to go ahead and write it out to the tenths or hundredths. So that would be meters cubed. All right, here's another one. So remember, volume is 3.14, which is our approximation of pi. Then R, if we look closely here, we notice that we have a diameter. So R is just going to be half that diameter, so R is 4. So 4 squared times the height, which is 8. So we'll bring in our calculator. 3.14 times 4 squared times 8, and we get 401.92. So volume equals 401.92 inches cubed, or cubic inches. Okay, let's keep it going. Here's one that's a little not so tall, a little wider and kind of squattier looking one, but we still use the same formula. So volume equals 3.14 times the radius, in this case is 7, squared times the height of the cylinder. All right, so we get our calculator out there one more time. And we do 3.14 times 7 squared times 5, and it gives us 769.3 feet cubed. Okay, that's a little bit of volume, huh? All right, so we might get a couple story problems that look like this. A company makes steel rods shaped like cylinders. Each rod has a diameter of 4 and a height of 90 centimeters. If the company has this much steel to work with, or this how much steel they use, how many rods did they make? Well, first of all, we got to find the volume of one rod. So we're going to find the volume of one rod. So that's going to be 3.14 times the radius squared. Now look, they said the diameter is 4, so that means the radius is 2. So 3.14 times 2 squared times 90. Okay, let's get that value so far. This is for one rod. So calculator, 3.14 times 2 squared times 90, and that equals 1130.4 cubic centimeters for one rod. So now we've got to divide this big number up here, this 30,520.8 divided by 1130.4. So using our calculator, and I'm going to get a calculator going. So 30,528.8. Oh, I'll do that one more time. 30,528.8 divided by 1130.4, which equals 27.00. So the answer is 27.0. It says do not round your answer. So apparently, let's go back to that calculator. It'll do 27 rods if we did our math correctly. So maybe we should check that number one more time. Let's do that one more time. So 3.14 times the radius squared times the height of 90. So I'm going to do the volume of one cylinder one more time and make sure that we've got it right. So 3.14 times 2 times 2, which is 2 squared, times 90, 1130.4. So that's how much it is for one cylinder. And then they've got this much still, so how many rods can we make? So let's do that again. 30528.8 divided by 1130.4. Yeah, so it looks like if you tried to round it at all, well, we're just going to round it up to 27 rods. So 27 rods. And they might make these so that they can send these rods to somewhere else where they can take the steel and use them for some other manufacturing process. Okay, how about candles? That's a good one. So a company makes wax candles in the shape of a cylinder. Each candle has a diameter of 6 inches, which means that its radius is going to be 3 inches and a height of 4 inches. How much wax will a company need to make 170 candles? So let's start out with one candle. Volume equals 3.14 times the radius squared times the height. So when we do that, when we get that number, we're going to times it by 170 to find out how much it'll take to get 170 candles. So let's grab our calculator and give that a try. Clear off what we have there. So 3.14 times 3 times 3 times 4 times 170. And they said to do not round our answer. So it would be 216.8. How much wax will a company need to make this many candles? So this unit is inches cubed. Sounds like a lot, but it adds up fast when you're running a company that's making lots of candles, right? And then if you know you need that much wax, you can find out how much it costs for each cubic inch and start figuring out your total cost. Okay, here's another one. We got a swimming pool that has to be drained for maintenance. The pool is shaped like a cylinder with a diameter of 7, which means that the radius of the pool is 3.5. And a depth of 1.4. So depth is 1.4. Okay, now the water is pumped out at a rate of 16 meters per hour. If the pool starts completely full, how many hours will it take to empty the pool? Well, first of all, we've got to find out how much water is in the pool. So the volume is 3.14 times 3.5 squared times 1.4. So let's do that multiplication. 3.14 times 3.5 times 3.5 times 1.4. And so we end up with 53.851 cubic meters in the pool. So now we've got to divide that by 16 to find out how many hours it will take to drain it. So back to our calculator. Hey, we still have our original number on the calculator, so all I have to do is divide by 16, and we get 3.36 hours. So round your answer to the nearest hour. So the 3.36 will round to 3 hours. And there we go. Okay, so we're going to do volume of cylinders. Alex assignment. And we'll put a number on there when we assign it on the board. Actually, trying to think which one it is. Anyhow, it'll be the next one. You can find it on the Today button, and it's going to be up there around 100 and something, because that's what assignment we're on right now. So good luck and have fun.